Hello again, YouTube peoples. I have a project here where I may be biting off more than I can chew, but why not? Right, so this Marshall came in and it was not making any sound. This just wasn't working. So I checked it out, and this unfortunately has a bunch of burnt spots on its inner printed circuit boards. Right, so I did my best and I tried to fix what appeared to be the physical damage of the burns and so on. And the amp started to get worse and worse. It started blowing fuses. I haven't been able to figure out what the next step would be. So I spoke to the owner and he said, man, forget it. I don't care to spend hundreds of dollars to even figure out what's wrong with that amp. Just forget it. Let's scrap it. I said, okay, because it's going to incur costs even before we figure anything out. It's got mismatched power tubes, the burns to the PC boards. There's so much work that we would have to do, retube it and so on. We'll spend in hundreds of dollars before we even get to figure out why these fuses are blowing and so on. So it's been scrapped and it's been sitting in my workshop here for a while. And it's suddenly, I thought about it and I called the guy. I said, listen, you really want to, can I have the amp? Can you give me the amp? I want to play around with it. Maybe I could get some spare parts and stuff. So he agreed and he just abandoned the amp and gave it to me. So what I'm going to do, I think would be fun, and that's why I'm filming, is I'm going to scrap down this TSL. I have no regard for these amps. These modern Marshalls with the million knobs, they have all kinds of circuit board problems. Look, there's another dead one right here. That's a DSL. I have no regard for these amps. And when I look at the construction quality and the circuit boards and their complicated nature, I just don't care for these things. I don't even want to work on them. So I thought it'd be a fun idea to strip this down and make it into a Resto Mod JCM800 2203. That is the 6-knob, 2-input jack, classic JCM800. Reuse whatever I can of the amp, but obviously gutting out the inside circuit boards and getting new face plates, so that I'm basically going to remove all these knobs, all these pots, and just put a JCM800 style faceplate and rebuild the amp to those faceplates, control layout and so on. So let's get a further look inside and let's see the damage that caused me to abandon this amp. Okay, looking inside, you can see the very complicated nature of its construction. I mean, let's count them. 1 circuit board, 2, 3, 4, 5, 6, 7. There's 7 overlapping circuit boards in this amp. Low quality pots, let's be honest. I'm not really looking to beat up Marshall too much. They've gotten along. This is their flagship type of product. What do I know? Okay. But the fact is that they're just about impossible to diagnose. I'm aware that there are TSL and DSL amps that have known issues with their circuit boards to do with the biasing. And some people just recommend replacing the circuit boards. Look at this. This has had some work. All of this stuff with the masking tape on it, I didn't have anything to do with that. This was some kind of questionable work that was done before I came along. Okay? And this is just the inside. So let's look on the top side where the power tubes go, and let's look at a very incriminating circuit board. Okay, so I've loosened out all the screws already, but there's this top panel that's on top of the chassis, and it corresponds with the largest circuit board that I showed you on the inside. So there's a little bias board too that normally pokes out here. When I got this amp, that bias board wasn't even mounted there. It was hanging by its wires inside the amp. Right now here, see this? This is a cleaned up version of what I dealt with, because when I got this, all the black soot was there. Right? Look at that. This is actually cleaned up. How's this? So here we see The circuit board has been completely burnt through there. And I actually did try to bypass the missing traces with the solid wires. And again, this was just literally hanging around in there, flopping around like just loose. Okay. So anyway, no one's interested in fixing this. Neither me nor the owner. So what I want to do, I could put this panel back here, or I could get rid of this and just make a new plate, aluminum plate, that covers this area and gives us a fresh start on where we want to drill the holes. I could do either one, is fine. And on the inside here, I can gut out all of those 7 circuit boards and replace them with a nice hand-wired JCM800 style circuit board, which is the same as the JMP master volumes, which is a very standard thing. I mean, I don't even have to make that. I could just buy those already wired up and everything. So common. And if I put a JCM800 style backplate too, I could eliminate these unnecessary controls and features, effects loop and all that stuff, and just have the JCM800 and drill the right holes for that back panel, including like the transformers in modern DSLs and TSLs. JCM900s are criticized for being a bit on the small side. Would agree that they are smaller than earlier style transformers, but you know what? I don't think that I need to change those to do the project that I want. I think I could still use these transformers. I hope they're still good. My goal in breaking this down tonight and starting this video is just because I want to get those transformers tested for continuity to begin with, and therefore I could proceed with this project. What would I need? What I would need to buy would be the 6 pots, control pots that I use on a 800. The model that I'm talking about would be the 2203 control pots. I have the knobs here already. I have the on-off switch here already. I think there are enough jacks here already for me to work with. There's about 4 or 5 of them here. And I only need 4. New 9-pin sockets, 3 of them. I'll need 4 8-pin octal sockets. Circuit board, hand-wired style circuit board that I mentioned. That's easy stuff to get. And some variation of a bank of capacitors to do the power supply filtering. Now, normally on a 2203, JCM800 and earlier, they would have the big blue LCR or daily can capacitors. But those are a little more expensive than smaller modern axial and radial types like these, because these are doing the job of that those big old cans used to do. But sometimes they have as many as 5 of those big blue cans, and they could get a little expensive. You're talking about over $100 US in capacitors. Then I would need the faceplate set, but we're looking at about maybe $300 worth of parts. I haven't even considered tubes yet, to be honest. We might hit 400, okay, in parts to cut this and redo it JCM800 2203 style. I also think I'll need to put in a choke as well. I don't have to, but maybe I might put in a choke too. I've been spending some time here just testing and labeling the power transformer and output transformer, but it's just little things that really turn one off of the modern Marshalls. I'm just looking at the back here. I can't even get the high tension fuse out of its holder. I mean, come on, man. This is a professional piece of equipment. This should be serviceable in a sort of a backstage environment. Look how chewed up all the plastic is on these fuse holders from people using it before I ever got to it. You know, I literally can't get this fuse out without ruining the plastic and maybe the clip that really would hold it in place. It's just garbage like this that turns me off of the fucking modern Marshalls. Okay, so I spent quite a bit of time staring at this section here and staring at the relevant schematic. and making little marks that for me are going to be relevant later in laying out where all the new components hook into the power transformer. The main thing I'm testing for is that each separate winding has the correct continuity and has a reasonable resistance from one terminal to the other within each winding, and testing to make sure that there's no windings that measure any continuity to each other. I think I will be hardwiring this to 120. I haven't quite figured out if I can do a 240 switch, which I don't need, but just thinking ahead. The output transformer, even more straightforward, testing that there's reasonable resistances on each winding. Okay folks, I got my parts from CED for our intended victim over there. What I haven't ordered yet, it's going to stall the job a bit, is a JCM800 faceplate, which I'm about to order from Mojotone. So that's going to be a gap between until I receive that. Okay, so let's do a little unbox, which is part of the fun of these projects. And I have a few extra parts for other projects too, like a deluxe reverb and a PRS amp. Okay, so very well packaged. We have some cardboard, brown paper stuff, and this is a deluxe reverb output transformer from Hammond, which is going to go on that little deluxe reverb down there. Maybe a separate project video. This is a big sturdy Fender Bassman power transformer, and this is for a PRS amp over there, which has blown up power transformer, and I think that this Bassman one would be a good replacement. It's the right size footprint, and the windings and voltage and current ratings are appropriate for that PRS Sonzera amp with a toasted power transformer. Okay, so we continue to fight through our brown paper. Right, so we've got boards. This is what I want to do. I ordered from CED, they carry a JTM45 board with turrets already installed. Now, so all I have to do is add in a few turrets somewhere on either end, whichever end it is. And this is going to be suitable for any of the 4-input circuits or a JCM800 circuit. Both this phenolic board, which is nice and thick, and I bought packets of the same type of turrets, and I'm going to make up a turret board here, which is going to account for the capacitors, filter capacitors of the power supply. So this is power supply, rectifier, and this is going to be preamp and phase inverter. Okay, let's do a scan through. We have filter capacitors here. These are 220 microfarad. I'm using those for the plates and screen power filtering on the brown board over there. The 50s, I have some 40s here, and those would be preamp for the Marshall. So these four and these four are going to get laid out here in the turrets section. Other than that, I'm not going to dig in here too much before moving on, but I have my pots, control pots. These are all alphas, and I use alphas because I wanted to use CTS because CTS is more expensive and it's higher, supposedly higher quality. But in my 25 years of repairing guitars and amplifiers, I have replaced more CTS pots in modern guitars than I would like to. I've used alphas for my whole career of building guitars because they were just a couple dollars cheaper, and amps too, and they never failed, right? Whereas I'm putting brand new CTS in guitars, and I'm having them make noise and stuff within a couple of years, and I don't like that. These are fuse holders, sockets. These are very high quality Belton sockets. I love these. These are what's in the Marshall now, but these are different type of connecting pin here. This is for hand wiring. We'll get to that later. And everything else is just resistors, various resistors. These are turrets that I'm going to add into that brown board. That's what they look like in their raw form. What else? That's about it. That's about it. This is a big capacitor for the cathode, 0.68. I should have bought more of those actually. Okay, here's a kind of dumb thing about these boards. Or not really dumb, but it's outdated. Is that if you're building this, you would typically use carbon film resistors, which are what Marshall used back in the day, not carbon comp like the old fenders. Here's an example of a carbon comp, which is the brown with the sort of sharp edge cylinder, and the carbon film are typically a cream rounded edge cylinder. The problem is the spacing of this, which may be correct to old Marshall specs, the spacing distance between here and here. The half-watt lead does not go that far. The leads just touch from one turret to the next, but not enough to make a solid solder joint. Now, for most connections, you don't need the half-watt to go right across the board. For example, this one here, a half-watt goes here, and it can make that shorter distance. And these usually take some half-watts between the center point and here. So over here, there's a run that takes a 820 ohm resistor, and it's usually next to a 100K resistor. So that's just a one little kind of outdated feature of this. It should be a little closer for half-watt resistors. What we have here in the package still, we'll be discussing these extensively over the project, are brightening capacitors. The main difference between any model of vintage Marshalls, besides obvious things like tubes and wattage, the main difference between one model to the next within a wattage are the brightening capacitors. The capacitors that jump across the volume knobs, and some of the 470K ohm mix resistors that are closely connected to the volume controls. And the value of those capacitors determines whether a model is a lead or a bass or organ or PA. And those are main differences of the models. And that's it, because you know those amps are 95% the same thing, or 98% the same thing. And the value of those capacitors determine how bright the amp is going to be. So if you have 4700 brightening cap, it's going to be brighter than an amp with a 470 brightening cap, which is 1/10 the size. So I bought some 470s, and these are going to be used at certain spots in the circuit to determine how much upper bandwidth we're going to have, how much upper treble. And is it going to be a fizzy tone? Is it going to be too bright, or is it going to be a warmer tone? All that comes down to your brightening caps. We'll be discussing this a lot, right? So what I'm going to do, I looked at this and I wondered if I'm going to be able to reuse this piece of metal with new sockets. So with the sockets in hand, we're now going to check to see the spacing. Now these are the same brand as before, as the originals. And you can see that that does fit. The hole fits perfectly, and the bolt holes fit perfectly as well. This is what it looks like. That's perfect. Yeah, see, this doesn't fit. This is designed for a 7/8 hole, so this just drops through. There's no way to secure this in the in that hole. It's just not happening. This is the faceplate. So this is from Mojatone. And let's have a look. Right, so these are plastic JCM800 style plates from Mojatone. So they don't say JCM800. I'm going to sign my name here and say JK Resto Mod probably. This is actually closer to the JCM800 look than I expected. I thought I was actually going to get those gold painted plexi panels, which would have been missing this brushed aluminum finish. And here's the back panel. See, I'm going to ignore the main select switch, but everything else I'll be using this. And in the front here, pretty straightforward, right? Holding it up to the amp, it's actually a little longer, I think, than the chassis. Maybe I have to trim it a bit. But I'm going to get into that. That's going to be a whole section of this video, is putting this onto the chassis and drilling new holes. Now, try as I might, I try to find a socket that would fit this hole. It's a bit big. It's a little over an inch. And no socket that I could get my hands on would fit in here properly. They're usually like 3/4 inch or 7/8 inch holes. So what I'm going to do is make a little aluminum board to cover the holes and re-drill at the 3/4 size. So the thing to do now is to gut out this chassis. I'm kind of doing all gutting, but I'm going to leave these in place for now. This stuff just has to go. It would be this main board that's got problems, but I mean other stuff had problems too, you know. So I'm not going to throw it away. I'm going to keep these around in case I need them for other amps. But so I'm gutting everything out up to this corner. All of these knobs have been pulled off, and a 7/16 driver to get all the nuts off this panel. And I think once I have these nuts off, the faceplate will come off. Except I need to pop these out from the inside. Trying to manhandle these rocker switches out from the inside. Sorry, our light is poor at the moment, but anyway, pushing on some tabs on the inside. They're pretty hard to get out, I have to say. Ooh, once again, there's so many pots. There's 3 circuit boards full of pots and switches. You know, it's such a pity to break down something like this. It's a pity, but it's not working. Anyway, so, and then over on the left, there was a separate board bolted to the chassis inside there, which was for the reverb. You can see the RSA connectors there. So this, whew, what a shame, what a shame. What a shame that all this is now useless from some factory board issues that I am now no longer willing to get involved in. Right, I just disconnected a few spade connectors there, and this whole thing comes out. The treble board, the pot boards, and the reverb board. So now I just need to get off that back panel, which is more jacks than switches at this point. Okay, so I have yanked out everything except for the immediate transformer wires, which I mentioned before, and I'm going to leave this hanging around for a bit until I just make a notation of where those wires are going to go in my new wiring idea. And then we're going to look at the new plates over there and see what kind of headache I'm dealing with, where the new holes that I want may not jive with the holes that are there now. Alright, so looking at the back panel now, we already know that a lot of the holes are not going to line up. The problem is the square holes. The square holes are hard for me to drill or bore into the steel chassis. You can already know nothing's going to line up. But let's look at how crazy it will be. Right, so the IEC here overlaps with a previous line out, I think. And the old IEC holder there. So there's no way that we are, doing anything like that. So basically I just have to center it up here and drill these holes and maybe do some dremeling, because if I have to drill into raw steel, that's not really a problem. But when it's an overlapping hole, that's a headache, right? Here too. So, listen, we're rescuing a dead amp here. We're not building a project from scratch. It's not like I have nice raw aluminum to work with. This is a disaster. And look at the inside here. There's all these square holes where the pots came through before. So that's going to be an ultra headache. All right, so anyway, I get the idea. I need to nibble away at these steel bits remaining to get that back panel on. Okay, so here now we lay on the front panel, and not too bad through here. I have raw steel to drill into. There's a little bit of an overlap here and here, which I could probably, you know, shift around to get around. Shouldn't be too bad. The main concern is over here, because the old and new switches, it's a close but no cigar situation, where they're the same size, but these ones are set lower down and closer together than this JCM800 style one. So we've got to nibble away at steel on two edges of each hole to get those to fit in. That's going to be a bit of a headache, but everything else will be all right. This amp is going to look so stupid on the inside. I'm not really Mr. Popularity contest when it comes to how neat the inside of an amp is going to look. I'm not one of those guys. But we're going to be seeing all these dead holes with, you know, the new panel covering it. So you're going to see a lovely new circuit board, but a bit of a disaster on metal work on the inside. So that's it for now. Some drilling and dremeling to be done. Okay, so having looked at this panel over and over to decide whether to keep using it or to just put another blank sheet there and re-drill that, I think I'm going to go ahead and keep this panel. I love that the burn marks are there. That's going to be part of this story, right? One little concern I have is that when I put this board in, I have to put it in somewhere that doesn't bump into the control ports on the front panel at the bottom. Okay, so the other issue too is that we only need 3 holes, but we have 4 here. 3 of them as normal, as needed, but we'll have an extra socket here, which I could use to do an experimental extra gain mods, like, you know, those popular mods like the Jose mod or whatever, Lee Jackson mods or whatever, that were done to these things in the 80s that have a fame all of their own. We can use that to experiment, you know, at some point. So I will keep the 4 sockets going. This board is really a JTM45 board. Now, every time you see one of these boards, they're probably going to look a little different, right? But the difference between the JCM800 setup and the JTM45 is that there's an extra cathode capacitor and resistor pair in this area here, all right? So I may have to just drill and add in an extra pair of turrets for that extra thing. But I am prepared with the extra turrets that I can drill and install where needed. I'm actually going to start over here, which is the bias area and the phase inverter. I'm going to work my way backwards. So this is the signal capacitor layout, and 2 notes now are a little confusion over in the bias area at one end, and then the area for the first gain stages that I mentioned initially. Now, the confusion with the bias end is that there's so many different ways to do bias circuit and adjustment for it, right? You can do a 1 filter capacitor version. You can do a 2. Here we have the backwards diode where the AC voltage will be fed in. The negative half of the signal will go through a resistor, come into here, get filtered and smooth. Then we'll have some sort of a pot adjustment hooked up that will alter the negative bias voltage. But there's just so many little ways to do that. But basically this area here will be reserved for bias, right? Here is going to be the negative feedback resistor. I think that's it. Oh, and then right, and another of these is a 10K voltage dropper for the high voltage B+, right? So I've done these. These are for the between the phase inverter and the power tube grids. Which one is this? Phase inverter input, tone stack after the second gain stage, after the first gain stage. Right, so the problem here now is we have this big capacitor to put for one of the cathodes. The JTM45 only had one cathode resistor setup with its capacitor, so that would be these two here. These here, forming a sort of a triangle, were for 68K input resistors off of the input jacks. We don't need that. We only have one. Well, we have two input jacks, but it's not the 4-input setup, right? So we don't need any of these here, to be honest. So what I'm going to do now, I'm going to drill and put in a set of terminals, which would be sort of parallel to this here. We've got another one. We put one here, or we could just, I'll just neaten it up, make something look a bit uniform. Okay, so what I'm going to do is there's a hole here already, actually, right here. And I'm going to put an extra turret right in there. And I'll let this wide one hold this big capacitor with its 2.7 cathode resistor. It's going to be in parallel with it, right? This one could live the 10K, which is the second gain stage cathode resistor. Second gain stage, first gain stage. This is where they usually live. Well, I haven't remarked on the components themselves. These MET, I can't remember the other brand. I don't know if it's Vichy. But so these are some capacitors I'm just trying out. They're polyester, 630 volts. And my supplier, CED, carries them. I could have used orange drops or Mallory's for polyesters, but I'm just trying these out. If for any crazy reason I don't like them, I could swap them, but I don't think I'm really going to notice a problem or have that in mind. But the idea is that the old Marshalls used polyester capacitors, so that's what we're using. And fenders too, 60s fenders, 50s fenders, they're all polyester capacitors. The resistors here are 1/2 watt carbon film, unless otherwise noted. Okay, so I'm done with capacitors. As you can see, I jumpered the 1/2 watt one over this. The resistors don't make, the modern 1/2 watt resistors don't have long enough leads to deal with these wide Marshall boards. If you want to do that, you're gonna have to use 1 watt. I did buy some 1 watts for the plate resistors, and you could see that those do have long enough leads. Okay, a couple little things I mentioned before now haunting me. I said that 1/2 watt resistors weren't long enough to go across the board, but 1 watts were. Now I had a couple of 10K resistors that I ordered in 1 watt, and they're this brown one, but they're shorter. They're too short to go across. So these have the same lead length as the 1/2 watts. So anyway, now these 10Ks have to go, there's like a pair of them here, right? But actually they're wide in series. So I don't need to have the two here. I'm gonna drill one hole here, put a turret in, and have those two 10Ks live here, and I have a little extra space here, right? The next thing is I have two cathode resistors. One is 100K and one is 820 ohms, and they both go like this, like a Y. And neither of them are long enough to make this run. So I'm going to drill another hole and put a turret like right here where my fingertip is. Okay, now normally I do this kind of drilling on the drill press, but I just did this by hand with my hand drill. It was fine. 332 is the hole needed for these turrets. And one's going to go here, right in the middle of this. And another one to accommodate just the shorter resistors, right? So what I have to do now, but I do have to move it to the drill press now to sort of flare out the back of these things. There's just two of them. So how you do this kind of thing? I mean, I came up with this method so long ago. I just have this piece of steel I drilled some holes into. And the larger one, I just put it in the vise. So this just goes into the vise like that. I'll put a turret down in that hole, right? And then I put the circuit board over it in the right spot. And like, okay, we got the hole there. And then I just have to come from the top and press down any sort of cone-shaped bit of any kind, and that would flare out the bottom of that turret. Right, so we're out of that one-handed flaring zone. Of course, if I were making the whole board and putting in all the turrets myself, I would put a little more neat formal arrangement set up at the drill press. But just to put these two in is a pretty quick thing, right? Kind of flared out the bottoms there. Okay, so I'm back to loading the last resistors. I put on these capacitors here. These little ceramic ones, but I put them in quite loosely. I don't bend the leads as neatly as the resistors and so on, because these parts, especially this and this, are the most likely that I tear out later if I find the amp is sounding too bright or fizzy in the distortion and so on. JCM800s, well, the master volume circuit in general, sometimes has awfully large bright caps here, like 4700 picofarads. What's installed in here now are 470 in these two things. You also have large, can be too large capacitors like this, jumping the gain control. And that is one of the things that I find the stock circuit is too bright. So again, these are sort of put in place almost temporarily. Okay, so I'm done for now. I have one or two little questions which I'll address later on, chiefly with the bias setup here, because the bias circuit here is a function of the power supply. And the power supply in this, from this transformer set of wires, could be different to what I see on a master volume Marshall schematic. So I'm going to compose this. The question will be, what value resistor would go here? This could be like a 10K or 15K, no problem. And then I could put like a 47K resistor here in series with a 50K pot. That's probably what I'm going to do, but this main resistor here will remain a mystery for now. Okay, so that's about it. Again, the capacitors could change depending on how bright the amp sounds, but this is pretty much stock Marshall master volume setup. Okay, so the next thing I have to work on is a power supply board. So I have a blank one, there's no layout whatsoever, and I have all these turrets with which to compose a capacitor layout, right? Now, first concern is that just resting this finished circuit board there, I don't have all that much space. I don't have all the space in the world. I mean, this is a lot of space, but that full board can't fit there, right? So I kind of need to measure and work within a certain area. So what I'm going to do, let's say the board can only be this long, just mocking up for now. I have to lay out 5 capacitor filter sections, which are going to filter the power tube plates, the power tube screens, and 3 phase inverter. The last 2 will deal with the first 4 12AX7 stages, right? So there's 5 capacitor sections, right? Now, because the plate voltage and screen voltage of the power tubes are quite high, they're usually around 500, maybe a little less than 500. In this amp, I'm not even sure what the voltages will be, but let's estimate it's between 450 and 500 volts DC, right? Now, most of these capacitors that you buy are rated at 450 or 500 volts DC. So you really need a larger threshold of capacitor voltage rating to handle that, right? So basically what I'll be doing is putting 2 in series for each the plate and screen filter sections. These are rated at, these are 220 microfarad rated at 350 volts. Which means when I put them in series, the effective capacitance would be 110 microfarads at 700 volts. Okay, I don't really think I have anything to worry about. These capacitors here will squeeze right together and take up like just 5 holes to mount all 3. These I can squeeze up together. They have to go in series. I'll arrange them in the correct way when I'm doing the layout. And I'll have a couple extra holes here, just enough to put turrets in to do the diodes for the rectifier, right? Now, we don't need to worry about the bias circuit because that's already on this board. Here is going to get 2 rows of diodes, right? Main high voltage rectification. I need to redo these exact holes, spacing wise exact same, but with smaller holes. Okay, so here you see the calipers go right in. That's the 7/8 step there, and our socket fits into that hole just perfectly. All right, see? So I'm going to continue with the others. Okay, so we have these holes done and it's ready for here, but the thing is that the mounting bolts, I can't put this here and drill holes for the sockets. They overlap with the edges too much. So the thing to do is to make these holes bigger so that I get rid of that overlap here, these mounting points. And I need a hole that's big enough so this could just sit right in that hole. Right, so this is set up here, and we're going to be going all the way in, right, and through this hole. I know it's a lot of dancing around in circles to keep this board going, but I don't know, I keep swapping ideas back and forth between keeping this in use and just cutting a new sheet. But overall, I don't know, I'm still in love with the idea of keeping the burns there, right? Right, so this was the idea here, right? The new sheet sitting below, the idea is, Jesus. The idea is to make the sockets have a clearer landing pad for the drilling and mounting of the little bolts, right? That kind of thing. Okay, that's all. And I'm gonna line up the mounting bolts so they're going this way. That way, when I get to the wiring inside, pins 9 and pins 4 and 5 jumper together will have their leads coming like that to the back wall of the amp. That's where we run the heater lines, right? Right, a bit messy and oily, but we got our new mounting plate here. And it'll look like that from the outside. Or this way. Either one is fine, but I think I'm gonna put it on the I think I'm gonna put it on the inside. You got the idea, right? Okay. Not bad. I think this is working out real well. Right? Okay, so there were some holes on this tray already. So I just put some 4/48 bolts to hold them onto this plate, and then there's the same 4/48 bolts. I don't think I have to put nuts on the inside because they've managed to cut their own thread. The aluminum is thick enough to hold the threading, right, like that there. So once you don't over tighten it, it's a solid connection. So this is great. This is not wobbling around in any way. And we have our, next time I buy some sockets, I'll just pick up one for here. Okay, so these Beltons are very high quality. They're not the ceramic type, but the pins, you know, some people say the ceramics these days, the pins may not be so great. But anyway, these are tried and tested, right? And these are going to be mounting from the inside with the same little bolts over here. Right, so I'm done with this main base plate. We have our Beltons in. I'm not too particular about how I orient these, but I did set it up so that the ground pins, which are 1 and 8, will go towards the back of the amp, and the corresponding bias measuring resistors will be there. And this is real nice. This came out good. I have to just trim this a bit shorter tomorrow and neaten that up, but we are ready to drop that in the chassis. So we want to get this new faceplate lined up on this chassis so it sits right in that gap there, right? Now at the bottom lip of that cabinet, there's a bit of a lip, underbite, something, right? so I don't have to put the new faceplate exactly on the edge of the chassis. I've left about 3/32 of an inch there, right? Because as I say, a Tolex lip is going to cover about the first eighth of an inch, right? So I've lined up with some clamps the new faceplate over the chassis, and I'm going to take careful markings here, very, very careful, which are going to show me exactly where I need to drill my new holes and where I have to enlarge in these pieces for the switches and stuff, right? Very careful measurement. Right, so as you can see, what I've done here is I have pinned the back plate now exactly where I wanted it. I don't need that lip like before. This is a flush mounted one. And I've just taken a Sharpie marker and I've filled in the hole against a back strip of masking tape, right, that I put along the inside. And I've just drawn that outline there. So I'm gonna have to drill these as holes. Except for something like this, which I probably have to take a Dremel and spend quite a while nibbling away at the metal here to get it right. If it was aluminum, it would be much easier. But this is steel that's not so thick, but it's pretty hard. Okay, so this is kind of a real bad example of what I'm talking about. You can see through the light, the backlight here, that pretty much almost all of these holes are backed by a pre-existing hole that's overlapping them, right? So all of these I cannot drill. I have to Dremel that hole. I've just gone center punching, and I'm going to go over to the drill press there and make some small holes to begin with, like a 1/8 of an inch, and then enlarge each one to 3/8 of an inch. These have to go to 7/16. Like a rat tail file and a Dremel is how I'm gonna have to cut these. Okay, our panel nightmare is almost over. I've spent so many unpleasant long minutes with various Dremel bits, right? I'm not too happy with the IEC cutout. It's a bit high on this side. When I put in my IEC, it's got a gap here. I'm not too happy about that, but anyway, that fits. I think these are 1/2 inch holes. I'm not even sure. They may be bigger. For the fuses fit, I'm going to use switchcraft jacks for the speaker connections because I want one of them to be a shorting jack, which Marshall doesn't usually do. Usually they just have 2 parallel open jacks. But this one, I'm going to have a main and an extension, and that means one of them will be shorted. All right, so these fit. These are 3/8 holes. If I did the plastic jacks, these would have been 7/16, right? Impedance switch. This is going to use a regular 3/8 hole. I think this needs to be enlarged a bit. Look at this. There's so many overlapping, horrible holes that I had to make like oval holes. Ugh, look at that, look at that, look at that. Anyway, let me do the next step, which is going to be make things a little easier on the eyes. There was a very, very sticky residue on here that held on the faceplates, original faceplates, which I took off, but I damaged them a lot when I took them off because they were so sticky and they were such a thin aluminum faceplate that by the time I got them off, they really were horribly damaged. Anyway, I've taken off the adhesive surface, some aluminum tape. You know, this kind of tape uses ducting and so on. I'm going to put a strip of this aluminum on the inside and just kind of hide all these messy holes from the inside, just to in some way take away the eyesore of those overlapping holes and all these extra squares and stuff. Well, that doesn't look too bad. And I'll just set this aside. So we're covering up all these holes on the inside. The chassis just looks much neater to work in. Okay, so my big challenge now, having drilled all those holes and stuff, is just to install them and make sure that their holes are centered on each other correctly, on the faceplate and the chassis itself, so that they go in. And remember, I have to leave myself about a 3/32 lip here. And I have to make sure that that's happening all the way across. This is plastic, it's not metal, and it's not stuck on, so it tends to wanna flap off, right, on the edges and stuff. So at some point I'm gonna have to glue this onto the chassis, but I'm just gonna use like water-based glue, like wood glue. The area of concern to me is here, because I've got to push these lights in, the switches in, they're a pretty stiff push. And if you look at how the new and old holes sort of overlap each other, I'll be pushing into proper metal on one side, but I'll be pushing into pure plastic on the other. So I hope I don't cut anything or cause the plastic to split when I push these in. Right, so I've just dabbed on some wood glue, regular Elmer's, and I'm taking a toothbrush and very simply just smearing some glue, not the whole thing, just some glue. As I said, I don't want it flopping around, especially on the edges. Okay, so almost everything is in order here. Let's look at the back panel. We've got the IC, and again, I don't like this little gap here. But even trying other ICs, I couldn't get it any better than that. The ends clamped down while the glue dries. Very tough switchcraft jacks for the back. This will be our 3-way impedance switch. Blank this off for now. I don't think I'm going to be using this. And our fuse holders. Over at the front, I'm sorry to say, I severely... You see, this thing is still coming loose here. Okay. I severely misjudged how these are mounted. I even ended up scratching the faceplate a bit. But I really struggled with this. I didn't really study the way these switches can be mounted on the inside. These flaps actually come right out instead of just sort of forming a ridge on the inside. If I had known that sooner, I could have prevented a little problem, because I ended up getting, well, you know what, you can't even see it, but there's the tiniest little cracks were starting in the corners there, and I was just able to get around the issue by flaring out these back mounts all the way. Thank goodness I realized that. But for some reason, I scratched there. Well, anyway, so that's our first relic feature, right? So let's look at where we are now. I have to say we are much better off than when this project started. It's actually looks good. We have our aluminum inside here hiding the old holes all the way around. And our faceplate is on and all parts are mounted. Kind of temporary with the input jacks, right? I have to organize my input jacks. So what I can do next is put back on the floor, which is holding the tube sockets, and then we can start doing further fabrication with the red board, this brown board. That's going to hold the capacitors, power supply capacitors, and then we could start assembling and wiring in earnest finally. But I'm pretty happy with where it's at right now. Right, so we're together enough now that I've laid the chassis into the head shell, and it's looking good. I don't have any knobs. I've got to organize the knobs, but we can see that I've very well judged the bottom lip issue so that you can't see the bare strip. But the point of that was because I needed to close this gap here. If I put this all the way down, the gold part all the way down on the chassis, we would have had a bare strip there. And this looks perfectly good. So we're in action. We are in action here.